Welcome back to our discussion about the graphs and applications of linear functions. And in this video, we're going to focus on how to use average rate of change for functions, as well as applying parallel and perpendicular properties of slope to equations of lines. So let's jump in. Let's start with using the average rate of change. The average rate of change is something that is very useful for us to think about as we think about a lot of real life situations. Okay, you may be interested in how much have gas prices gone up on average over the course of the last 6 months. So you might look at what gas prices were in December versus in May, and then take the difference and divide by 6. Okay, so that would become the average rate of change. Now, when we're talking about the average rate of change of a function, that is going to depend on the 2 points that we begin and end with, and then divide by the number of units in between. Let's look at a parabola. If I were to choose 2 points on this parabola, let's say, how about -2, 2, and 1, -1? Can you envision the line that goes through these 2 points? It's not part of the graph, but you can kind of visualize what that line looks like. And the average rate of change of this function from -2 to +1, the x values, is going to be the slope of that line. Okay, so notice that that's going to change depending on the points that I choose. Let's keep that first point, but change the second point. What if I chose the point 2, 2? Well, then the slope of that line is going to be significantly different, right? Can you visualize that line? The slope here is going to be 0, right? There is no slope. There's no change in y value. Before we had a negative slope, here we have a 0 slope. And likewise, I can choose another point. How about, let's see, how about where x is 2.5? If I choose the point where x is 2.5, I get a y value of about 4.25. And notice my slope is positive. Okay, so it all depends when I'm dealing with a nonlinear function on the points that I choose to determine the average rate of change. Okay, so let's take a look. Here's an average rate of change problem, and I am given a function f of x is equal to x squared minus 2x, and I'm given 2 x values. x1 is 3 and x2 is 6. So I am going to use this function and these x1 and x2 values to find the average rate of change. So the very first thing I'm going to do is I'm going to sub in the values for x1 and x2 into this average rate of change function. So f of x2, which is f of 6, minus f of x1, which is 3. So f of 6 minus f of 3 in the numerator, divided by 6 over 3. Okay, perfect. Now, I need to know what f of 6 is. I also need to know what f of 3 is. That's where the function comes in. I need to find the function value when x is 6 and when x is 3. So f of 3 will be 3 squared minus 2 times 3. In other words, 9 minus 6, which is 3. f of 3 ends up being 3. Now I'll do the same thing for f of 6. f of 6 will be 6 squared minus 2 times 6, or 36 minus 12, which is 24. Now once I have f of 3 and f of 6, I'm going to sub those values into my formula in the numerator. I'm going to replace f of 6 with 24, and I'm going to replace f of 3 with just 3. Okay, So 24 minus 3 divided by 6 minus 3 will give us the average rate of change. And so that's going to end up being 21 divided by 3, which will be 7. Okay, so that really means that for every unit to the right I move, I will move 7 units up when I'm going from x1, an x value of 3, to an x value of 6. So let's try another example. For this one, let's find the average rate of change for the function f of x is equal to the square root of x, and x1 is 25 while x2 is 9. Okay, so let's use that average rate of change function, f of x2 minus f of x1 divided by x2 minus x1, and sub in x1 and x2. Okay, so we would end up with f of 9 minus f of 25 divided by 9 minus 25. Now, here's where I need to find f of 9 and f of 25. Let's find f of 9 first. Let's sub in 9 to our function. So f of 9 will be the square root of 9, which is 3. So f of 9 is 3. And f of 25 we'll find by taking the square root of 25, which is 5. So now I'm going to replace in my formula f of 9, which we know to be 3, and f of 25, which we know to be 5. So 3 minus 5 divided by 9 minus 25, and then I'll simplify. So 3 minus 5 is negative 2, while 9 minus 25 is negative 16. And so our average rate of change here is 1/8. For every 1 unit to the right, I will increase by 1/8 of a unit going up. Okay, so now let's move into parallel and perpendicular lines. Remember that parallel lines have slopes that are the same, while perpendicular lines have slopes that are negative reciprocals. So if I'm given a problem where I want to find the slope-intercept form of the equation of the line that passes through the point negative 2, 5 and is parallel to the line whose equation is y is equal to 3x plus 1, there's 3 things that really stand out to me in this example. One is that I'm given a point, right? I'm given this point negative 2, 5. I'm given an equation of a line, y equals 3x plus 1, which gives me some information on its own. And last, I want something that's parallel. And parallel should indicate right away I need to be thinking same slope, okay? So parallel. So if I know it's parallel to this line, well, what's the slope of this line? The slope of this line is 3. And so the slope of the line parallel to that will also be 3. I'm going to use this slope, 3, and this point, negative 2, 5, with point slope form to find the equation of that line in point slope form, and then I'll convert it to slope intercept. So y minus 5 is equal to 3, the slope, times x minus negative 2. Remember, to make our point slope form proper, we want to simplify to eliminate that double negative so that x minus negative 2 will become x plus 2. Next, we want to convert this to slope-intercept form, which means I'll distribute the 3 and then I'll add the 5. So let's first distribute the 3. So y minus 5 is equal to 3x plus 6. And then we'll add 5 to both sides to finish this conversion. And we'll end up with y is equal to 3x plus 11, which will be our slope-intercept form of this equation. All right, so this time we want to find the slope-intercept form of the equation of the line that passes through the point 4, negative 5, and is parallel to the line whose equation is 3x minus 5y is equal to 8. So this looks very similar to what we did before, except that our equation is not in slope-intercept form. So I want to remember that parallel means the same slope, so I need to identify the slope of the line that I'm given. But this is not in slope-intercept form, So I will need to change that by solving for y. I'll need to isolate my y. So first, take that 3x minus 5y is equal to 8. So we want to isolate the y. So let's get the term with the y isolated first. That will become 5y is equal to 3x minus 8. Now, if I divide everything through by 5, I'll end up with what I want, my equation in slope-intercept form. Y is equal to 3/5 x minus 8/5. This gives me the slope, right? The slope of this line is 3/5. And what I really want is the line parallel to that that goes through this point. So I'll use the same slope. All right, so let's use point slope form. Y minus -5 is equal to 3/5 times x minus 4. Remember that we're going to get rid of that double negative. So y plus 5 is equal to 3/5 x minus 4. Now, I want this in slope-intercept form, so I need to distribute that 3/5 through. 3/5 x minus 12/5. Okay, now the last thing I'll want to do is subtract 5 from both sides, and that will give me 3/5 x minus 37/5. Now, negative 12/5 minus 5 will give you that negative 37/5. And you may be thinking to yourself, why the heck did that happen? And that's because to subtract 5 from negative 12/5, you would need a common denominator, which means you would multiply by 5 over 5. We are really subtracting 25/5 from negative 12/5, and that's where that negative 37/5 comes from. You are welcome to use a calculator to get that. All right, now we have one where we're going to deal with something that's perpendicular. Find the slope of any line that's perpendicular to the line whose equation is x plus 3y minus 10 is equal to 0. So we want to think about the fact that since perpendicular means that the slopes have negative reciprocals, we need to find the slope of the line that we're given. We need to find the slope of this thing. Okay, so that means I need to put it in slope-intercept form so I know what the slope is that I'm dealing with. So let's isolate the y. Let's isolate the term that contains y. So 3y will equal negative x plus 10. And then when I divide through by 3, I'll have y is equal to negative 1/3 x minus 10/3. And that means that the slope of this line is negative 1/3. But I want the slope of any line that's perpendicular to this line. So I will take this slope and make it the negative reciprocal. Okay, so I will turn it upside down and change the sign. So instead of negative, it will be positive, and instead of 1/3, it will become 3/1, which is just 3. So the slope of any perpendicular line here is going to be 3. And our last example here, find the slope-intercept form of the equation of the line that passes through the point 5,1 and is perpendicular to the line whose equation is 5x minus 3y is equal to 6. Now, this looks like putting together several things that we've done in previous examples. Remember that we're identifying that this is perpendicular, so we're dealing with negative reciprocal slopes, and I have an equation that I can find the slope of the original line from. I'll need to put that into slope-intercept form to find that slope. So let's isolate the term with a y. So when I do that, I get 3y is equal to 5x minus 6. Divide through by 3. So y is equal to 5/3 x minus 2. And that gives me a slope of 5/3, which means the slope of any line perpendicular to 5/3 will be negative 3/5. So now I need to take that negative 3/5 slope and use it with the point 5,1 to find the equation of the line that passes through that point. So let's use point slope form again. Y minus 1 is equal to negative 3/5 times x minus 5. I don't have any double negatives here that I need to get rid of, so I can go ahead and begin my conversion to slope-intercept form. Okay, let's give that a shot. So let's distribute that -3/5 through. If I take this -3/5 and multiply by x, of course I get -3/5 x, but -3/5 times -5 will give me +3 because those 5's will negate each other. So I have y minus 1 is equal to -3/5 x plus 3. And when then I add the 1 to both sides, I will end up with y is equal to -3/5 x plus 4. And that will conclude our discussion about parallel and perpendicular lines. And I'll see you next time.